Hello everybody, this is Mrs. Lindsay. Today we're going to talk about evaluating limits algebraically. We're going to use this set of notes for 2 days, so just a little FYI with that moving forward. Okay, so first of all, let's evaluate this. Well, the first approach that we're going to do, or that we're going to look at, is as the limit of x approaches 4 of the function x squared minus 11, we're simply going to plug in 4 for x and see what we get. So we get 16 minus 11, so that gives us 5. And this is actually the limit. This method is probably the easiest method, but it is called direct substitution. This is always the first thing you want to try. Every single time. You want to try this first. But we do run into situations here in which a limit as x approaches a certain value is not the same as the function value, okay? And this is what we would call a hole, okay? So we have to use our algebra toolbox to think about how we could actually simplify some of these things to help us actually find the limits of these. So this hole is also called a removable discontinuity, though. Okay, so let's think about some of the algebra things we've done in the past. Okay, well, first of all, factoring. So if you plug this in, though, I don't want you to forget about direct substitution. You should try to plug 1 in here first. What happens is, if you do that, you get 0 over 0. This is called the indeterminate form. That means, okay, what else can I do? What can I use algebraically that I know how to do to help me simplify this function to figure out what the limit at 1 is? Okay, so in this case, we're going to factor. So the top portion is going to factor into factors of -4 that add up to 3, would be +4 and -1. And as you can see here, we have things that cancel. So now we have a simplified form of simply the function x plus 4. Now we go right back to direct substitution and we plug 1 in, so we get 1 plus 4. So we get our limit as x approaches 1 to be 5. Okay, we're going to skip this example over here on the right and we're going to go to our next method that we could use. Now realize how this looks here. It looks completely different than the other one. You don't have polynomials here. You have a fraction within the fraction, a complex fraction. So again, the first thing I want to do is plug in 0, but as soon as I see that I have a 0 in the denominator here, now we're going to run into trouble. So we need to, again, use our algebra toolbox here to think about things we can do. I'm going to show you 2 different ways of doing it. The first way I'm going to show you is find a common denominator. Well, that means in the numerator here, since I have my fractions, I know I'm going to have a common denominator of 2 times 2 plus x. So the fraction on the right, I'm going to multiply top and bottom by 2 plus x. And the fraction on the left, I'm going to multiply by 2. So now I'll get that to be the limit as x approaches 0. We just need to kind of keep bringing this down until we get to a point where we can plug in and do direct substitution. Okay, so you're going to see this notation, how I keep writing that until I plug it in. But I'm just going to look at the numerator here. So now I have 2. And then this is going to be 4 plus 2x, because I got to distribute that through. Minus, and then this is going to be 2 plus x in the numerator. And again, 4 plus 2x. And I'm not doing anything with the denominator because it's simply just x. So now I'm going to subtract in the numerator, so it's going to be 2 minus 2, which is 0. Please make sure you bring through the negative because it becomes negative x in the numerator, all over x. Now I'm going to do this division. Well, if you recall, I can also write that division. This is written as a fraction or vertically. This is written horizontally here. Well, how do I take care of this division? I change it to multiplying by the reciprocal of 1 over x. Now things cancel. You'll see here this x cancels. Now we have the limit as x approaches 0 of -1 over 4 plus 2x. Now again, we've simplified it. We can go right into direct substitution. So if I plug in 0, we get that to be -1/4, and that is the limit. Okay. Now, exact same problem, but I'm going to show you the method of multiplying by the baby LCD. Well, what does that mean? Well, these 2 plus x and 2 are what we call the baby denominators. Again, that's not an official term, but the denominators within the smaller denominators within the larger fraction. Well, if I multiply top and bottom by the LCD of that, well, in this case, it'd be 2 times 2 plus x, and I multiply that in top and the bottom. So here I distribute, and in this case, the 2 plus x would cancel off. So I would just literally get 2 times 1. So this would be the limit as x approaches 0. And again, so that would be 2. Now if I distribute here, this time, this is going to remain the 2 plus x, but now the 2's would cancel. So I got to bring through, and again, make sure you keep that negative with it. So now it's going to be -2 minus x all over my denominator here. So this is going to be, I'll just multiply the one portion, 2x, and leave the 2 plus x in parentheses for right now. Okay, so let's simplify a little bit more. 2's go away. And you're going to see that this should look extremely familiar. Still got to cancel these x's. You can do that in one step if you'd like. I just wanted to show you the steps there. So it's going to be -1 over 2 times 2 plus x. And again, the only thing I didn't do, it's very similar to the one we had in the previous method. It was 4 plus 2x. Again, the exact same thing there. So now when I do direct substitution, and then we plug in 0, and then again we get that to be -1/4 as our limit. Either method, whenever you see a problem that looks like this, it doesn't matter which method you prefer. If you prefer one over the other, if you like to use mix it up, that's totally fine. Both of these methods will absolutely work. Okay. Okay. And the next type that we can use for help reducing these would be using the conjugate. Okay, so wherever we see a radical here, you see a fraction, but we want to do the conjugate of the numerator in this case because our radical is in the numerator. Doesn't always have to be in the numerator, it can be the denominator as well. So the conjugate, if you recall, is the exact same thing of your binomial here, but you change the sign. And I'm going to multiply top and bottom by that. So, when I distribute, okay, what happens when I distribute in the numerator, because I'm multiplying by the conjugate here, the middle two terms will always cancel out. Okay, so if I show you the distributing over here to the right, because I typically skip this step, square root of x plus 9 times square root of x plus 9, that just becomes x plus 9. Now I have plus 3 square root of x plus 9. Keep going. -3 square root of x plus 9 minus 9. So again, these will cancel. Every single time the two middle terms will cancel. Okay? And if you need me to explain this a little bit more in detail, when I take the square root times the square root, why does that just become x plus 9? Because I have the square root here, and it becomes x plus 9 quantity squared, which would then cancel. So again, this would be x plus 9 minus 9. When I simplify it, the middle two terms always cancel out. And the denominator, I'm literally just going to leave it as x times the radical x plus 9 plus 3. Now I'm going to simplify. So what happens, the 9's cancel out, and the x's cancel out. So then I have the limit as x approaches 0 of 1 over the radical x plus 9 plus 3. Now we go right back to direct substitution. So I'm going to have 1 over square root of 9 plus 3, which is going to be 1/6. All right, and those are our methods that we are going to use to practice these. Okay, so I would actually like you to try 3 problems here. I would like you to try number 1. Flip the page. I would like you to try number 4. And I would like you to try number 5. When you're done, push play and check your answers, and then we will do a couple more examples. Okay, so for the first problem here, simply factor, and then you have your x plus 1s cancel out, and then we do direct substitution, and you get that to be -5. And again, the first thing, I cannot stress this enough, the first thing you want to try is always do direct substitution. In this case, you get 0 over 0, which is in that indeterminate form. So then again, you go to your set of toolboxes and think about, okay, what can I do? Multiply by the conjugate, factor, those types of things. Okay, so same idea here with number 4. I did not finish this one because I wanted to stop at this one point in time, but you're going to multiply by the conjugate, and it should reduce down to what I have here, x squared minus 16. Well, that doesn't cancel. However, if you recall, what does this actually equal? Well, it's a difference of squares. It's a dot. So I can rewrite that, and now I can see that x plus 4 cancels. So my limit as x approaches -4 over, so I get x minus 4 over the square root of x squared plus 9 plus 5. Now I can go ahead and do my substitution. So when I plug my substitution in, I get that to be -8 over 10. And again, we always want to reduce, so -4/5. So here I had to actually use a little bit of both. So I had to do a little bit of factoring, and I had to multiply by the conjugate. You again, just keep using what you know about your algebra to keep reducing and simplifying. And then number 5, I didn't want you to forget this one. This is the one where you, again, just do direct substitution. There's nothing fancy to this one at all. But please don't forget that is absolutely the first thing you want to try. Okay, so let's keep going here. Let's go to the next page. Again, I'm skipping around here a little bit. We're going to do number 9. Again, direct substitution. So 2 cosine 3 pi over 4. All right, we got to think back what we did the first semester. Where would that be? Well, that's going to be in the 3rd quadrant. Hopefully you again remember it's going to be -√2 over 2 because it's your x value of your ordered pairs then that's going to reduce to -√2. Again, so we're only just simply doing direct substitution there. 14. Let's try this guy. Okay, so if we plug in 0, we get this to be 9 minus 9. So again, you're going to get that indeterminate form. So let's think about what we can do with this one. Well, let's actually just FOIL this one out. Let's see what happens if we distribute that. So 3 plus h times 3 plus h. Well, that's going to be 9 plus 6h plus h squared. And then minus 3 squared, so that's 9. We can see some things are going to cancel here, the 9s. And we're left simply with 6h plus h squared in the numerator. Now I can factor out an h, and it will cancel with the denominator. So now I simply have to do the limit as it approaches 0, so those cancel of 6 plus h, and do direct substitution. So we get that to be 6. Okay, so now I would like you to try 2 problems. If you could try 16 and 21, and then push play when you are ready to check those answers. Okay, so 16 is simply direct substitution, plugging in, again, make sure you plug it in both the top and the bottom, so you get the left hand and the right hand behaviors, and again, they equal each other. So that means the limit is going to be 1. And then 21 is going to be, I did multiply by the baby LCD. You might have combined, but you get your answer here to be -1 over 9. Again, we are going to do a second day of this as well, but this concludes the first day of evaluating limits algebraically.